We're going to talk about a symmetric matrix. A square matrix A is called symmetric if matrix A equals A transpose. That's what A to the T stands for. But there's also another type of matrix when we're talking about symmetric matrices, and that is skew symmetric. A square matrix A is called skew symmetric if A transpose equals negative A. Let's go ahead and use these definitions. Determine if the matrix is skew symmetric and or symmetric or neither. Here is matrix A. It's just a simple little 2 by 2. When they give you matrix A, it is easy enough to find A transpose because again, what were the columns now become the rows. So column 1 is now row 1, column 2 is now row 2. A transpose does not equal A, thus it is not symmetric. Now let's find negative A. Well, basically you just take a negative 1 times matrix A, and when we find it, we get this matrix right here for negative A. Does not look like A transpose. So negative A does not equal A transpose, thus it is not skew symmetric. Again, both of these are using the definition. Thereby, we can say matrix A is neither symmetric nor skew symmetric. New example, we have matrix A right here, 3, -4, -4, 5. And first thing that I like to do A transpose because it's very simple. Change the columns to rows. And when I do, I notice that A transpose equals matrix A, so we can say that it is a symmetric matrix. Now we're going to find negative A. I always do that second. Why? I don't know. I just do. It doesn't matter the order that you do it in. So when I take negative A, I get this. Negative A does not equal A transpose, thus it is not skew symmetric. Let's try another example. Here's matrix A. All right, lovely. A transpose. Rows became columns. Columns became rows. However it is that you want to say it. Much better. Thus we can say A transpose does not equal A. They look nothing alike, so it's not symmetric. If I do negative A, alrighty. Notice, guess what? Negative A equals A transpose. This is skew symmetric. Since what we did basically means nothing to you, what we're going to do is I'm going to give you matrix A. And then I took A transpose. And then from matrix A, I also did negative A. And notice that I got stuff in green and orange. What I'm going to do is use actual row vectors. So I'm using this as a row vector, this as a row vector, and so on. By putting them in green and orange, you're able to identify them on the graph. So this is matrix A graphed. Doesn't look like anything, it just looks like a normal vector graph. Cool. This is A transpose. Still not thrilled, but we graphed it, okay. And there is negative A. Let's work with these 3 graphs. Again, this is A transpose, and this is negative A. What is this skew symmetric and what is this symmetric matrix that we're talking about, and what does it look like graphically? Let me show you. What we have on this graph is A, which is in orange, and A transpose. A transpose is in pencil, and the other one is in orange. And then I have this dashed line right here. Now, if you know anything about graphs, you know that this dashed line represents y equals x. In our regular algebra classes, we would call these inverses. because they are the same distance from this line, y equals x. These are what we would call inverses. This vector is the inverse of that vector. This vector is the inverse of that vector. So if we were to consider this to be one graph, then the inverse of this one graph would be this other one in orange. If A equals A transpose, we call this symmetric. And there's symmetry on the y equals x. That's what this is all about. Symmetric is dealing with symmetry on the y equals x line. There's your graphical approach. Now let's discuss A and negative A. So A is the one in orange. A is this one right here. And the one in pencil is negative A. And what do you notice about those? Take a look at the signs for 2, 3, and negative 2, negative 3. Negative 3, 4, and 3, negative 4. When we learned this a long time ago, we would call this symmetric about the origin. It is symmetric about the origin. When we look at the points, we would notice that all of the signs change. Negative 3, 4 becomes 3, negative 4. All of the signs change. This is what we call skew symmetric, even though in algebra we would call this symmetry about the origin. So that's what's going on behind the scenes when we ask for skew symmetric or symmetric. So that's what we're talking about when we talk about symmetric and skew symmetric. Skew symmetric is symmetry about the origin. Symmetric means symmetry on the line y equals x. Let's take this example because I can hear somebody asking the question, what about negative A and A transpose? What if they equal each other? What does that mean? Well, if you take a look at our graph, A is the one in orange here, and the one in pencil is the A transpose. It is symmetric about the y equals negative x dashed line. But does it have a name for it? I have no clue. I really don't know. But it is interesting how if negative A equals A transpose, you do have some type of symmetry going on. But again, it's around y equals negative x, not y equals x. Is it called something? Not as far as I know. I have no clue though at the time of filming this video. Let me know in the comments below.